Hey, welcome to another live Wells Tech training class. We are so happy you are here. With me today I have Mike Becker, and we're going to bring in Darrick Prill. He is one of our engineers on the EVAP emissions team. Okay?
Perfect.
All right, but before we get started, let's talk about this.
All right.
Yeah, the cool t-shirt giveaway. Yes, and here's your question of the day. When the vent solenoid is normally open, wait, the vent solenoid is normally open.
That's a fact.
That is a fact, Jack. And when is it activated and closed? When is it activated and closed? Question A, during fuel fill-up, during the EVAP monitor test, when the fuel tank is nearly empty, below 15%, all of the above, or none of the above. There you go. Answer that question correctly. Text it in to us, and we'll get a t-shirt out to you real quick.
Perfect.
All right? You send Mike an email.
Yep.
We'll bring up his email address in just a little bit. Okay, last time out. Let's talk about that.
All right.
Okay, we are looking at EVAP problems, and what vehicle did we have in here?
Right, yeah,
Your
yeah.
vehicle.
We have my grandma.
And by the way, it's for sale before you, okay, all right.
Nice.
Okay, go ahead, I'm sorry.
Yeah, we had that P0445 large leak code on there.
Okay.
I remember we were trying to find out a way to prove that that vent solenoid had failed.
And that's a problem.
Right.
You know, we ran a bunch of different tests on that, and, you know, we didn't come up with anything real decisive, you know, saying, hey, do this test,
Right.
you can find out.
Right, exactly.
Okay.
And I had to get through emissions, so I kind of had to go off of some experience and some, I don't want to say educated guess.
It is an
It
educated
kinda
guess.
was.
That's what it was. And that's the information we're going to give you today.
Mm-hmm.
And you'll be able to talk to your customer with a lot more knowledge about vent solenoids. Like when you come to a point like Mike did, everything else checks out good. What do? You
Yeah.
replace the vent solenoid.
Kind of at that impasse, and
That's right.
you got to make a decision.
You got to make a decision. And we did have a viewer, let me see if I can get this right.
Yeah.
NCP, what is that?
D.
DFSB.
Yeah.
Okay, and that's Drew, by the way. And what does that stand for? Nautical?
I don't, something police department.
Yeah, I believe he repairs police cars. Okay, which is a lot of fun. I can tell you some stories about that. But what Drew said is he suggested that we should cut some of these open and see what the heck is inside, and
Right, yep.
see if we can figure out why they're failing. Well,
Dissect it.
right, dissect it, and that's exactly what we did. And that's what we brought Darrick in here to do, is help us explain that.
Exactly.
You know, how exactly do these things work, and what do we see causing them to fail?
Right, yep.
Okay, and how can we look for those kind of things when we're doing a diagnostics?
Right.
Okay, all right,
Things to look for, and giveaways
right,
of,
exactly.
what to watch for.
Okay, so without further ado,
All right.
let's bring Darrick Prill in.
Hi guys. Hey, Darrick. Hi.
Darrick Prill, he is a senior project engineer
Yes.
for the evaporative, this is why I keep notes, evaporative emissions team.
Yes, that's
right.
correct. Yep.
Okay, very good. How long have you been with Wells?
It's going a little over 3 years.
A little over 3 years. Excellent, excellent. And you do work, this is what you do.
Yes, vent valves, purge valves, vacuum switching valves, you name it.
That's cool.
Anything in the EVAP system, we're touching it at some point. So,
Neat stuff.
Yep.
And you have a lot of fun doing it, I
oh,
bet.
certainly. It's stuff like this is what I love, to kind of talk about anything we can dissect and kind of get into it. I love
Yeah.
it. So,
Well, that's what we're going to do right now.
sure.
Okay. Yeah, as a matter of fact, we have a new one here. This one right here. Is this a new one? Okay. There's a new one right there. If you want to just take a moment to, and we got a picture coming up here in a second to show them exactly what this is, but if you can explain the function of that,
Okay.
we'd appreciate that.
Sure. Well, now, essentially what you've got going on here is you're creating an electromagnet here. You've got a solenoid.
Okay.
So what you're going to do is, you know, when you want to actuate this valve, the vehicle is going to run current through this, and there's a little steel armature in the top of this, and what that does is when you send current through it, it's going to pull it to the center of the coil. It's going to want to pull it to the center, and what that does is there's a plastic plunger in here.
And that's this piece right here?
Yes, that's that piece right there.
Okay.
So now that, you know, you've got this plunger in here that's basically inside your coil, And when it activates that electromagnet, this steel piece pushes on the top of this and actually comes down and closes your valve. And then you've got another spring on the bottom side so that when your current is turned off, it returns your plunger back to its home position.
That's what this one
And that's what that spring is
Okay.
for right there. So that's the basic function of what's going on
And that's how they work when they're brand new.
when
Right?
they're brand new.
Right. When we take them off our line and all that, that's how they're working.
Yes.
Right. Now, we also cut open ones that had failed. Okay. And can you take that, grab this one here and,
Sure.
and do a little bit? By the way, this is the one that came off of Mike's car that we replaced last time. Remember, they had a big crack up the side of it.
Okay. Now I noticed, Mike, you'd said you noticed that crack here
Yeah,
on the
exactly.
side. And, you can see some, what it looks like appears to be rust.
Yep.
And now that's one thing that I've also seen before. The biggest thing that helps us, in engineering is if we can go to the junkyard, you find an old vehicle that's got some of these on it, we'll bring it back and tear them apart because, if you're designing these things, you want to be able to find out how they failed or what could potentially fail. So this is something that I have seen before as well, where you've got, rust that kind of forms, along this side here, and there's this steel portion in here that actually creates your core for your solenoid.
Okay.
So now, what happens is when you've got your filter canister here, you're going to be pulling in basically air from atmosphere, which depending on your driving conditions could be very humid air, and that could be pulling, moisture past here, which could start to, corrode this metal portion here. Now, I think you were saying something earlier on.
Yeah, when I was in getting this cut apart, Dennis had told me that rust can build up 2,000 psi, 2,000 pounds per square inch of pressure.
And Russ, explain who Dennis is.
Oh yeah, Dennis is one of our tool room guys that cut apart the valve for me.
Right. And he was saying, what does Russ do again?
2,000 psi of pressure it can accumulate, and that's probably what cracked that case on there.
So as that rust builds up, it
underneath.
just keeps building on a microscopic level, and then eventually ends up cracking your
Cracking out.
housing on your solenoid valve here.
And that could cause this to bind up inside there too, right?
Yes, and one of the things, not on this valve, but on another valve that I've taken apart, was, this plastic valve needs to move freely inside your core. And what I had seen is where basically the valve stopped in mid-position. It was, basically right in between your two ports. And, when I took it apart, took a screwdriver and I tried pushing that plunger back up, and it was extremely hard to do. So when I tore it apart and actually got inside, I could see that metal piece was, fully corroded, it had rust everywhere. And when I actually tried to manually activate this plunger a few times, it broke some of that rust free. And then it was able to actually
Move back
again.
and forth.
So,
Oh, boy.
So it's kind of an intermittent failure right there.
exactly.
So those are the ones that may feel like they're activating, but the plunger is not really moving.
Right.
So you got to check to make sure that you actually do and do not have flow through these, tubes when you're testing them.
Yes.
And I suppose it doesn't take much rust on there because this spring here is not very strong.
Oh
this
no,
return
it's
spring.
extremely light spring.
So if you get a little bit of rust built up on there, it's not going to this little spring here is not going to push it back in and cause it to stick in one direction or the other.
Exactly.
It's all really good stuff. It's really not dirt that's getting in there. It's mainly rust that's causing this.
From
Is
what
that
I've seen, personally, it seems to be rust and corrosion that actually, starts to make some of these parts fail.
Okay.
We've taken apart some of these filters before, and I don't know if you're going to be getting into that.
Yeah, we're going to
Okay.
take.
So now,
As a matter of fact, that's a good time to do it.
Yeah.
Let's do it now.
Yep.
Okay, so this is the filter. This is off of that new one. And so you pop the cap off, and you can see that there's a small little. Well, I
Filter.
think it's a filter.
It's
doesn't look quite
called
like
an
a
open
filter,
open cell filter.
But,
Right.
And we
doesn't
did.
look like it's going to stop much.
No, it doesn't, but it does actually.
Yeah.
And open cell filters, from what I understand, is they keep out the big particles. Okay. And if you look at this one closely, you can see that just the bottom side is really doing the filtering. And whenever you take one of these apart and you look down in there, there's a bunch of junk down in the bottom, a bunch of particles from it. If you tip it upside down, stuff comes out. We've already tipped this one, but we did have one more piece fall out. Okay, right there. But also, from what I had read, it does help a little bit with moisture too. It isn't, the cure-all by any means.
Yeah, and now there's a bunch of different designs of these, filters here, and some of them have patent numbers on them, and if you go take a look at, what the patent design actually says, and we've got some examples of this, but for this one, basically you're sucking in air through this center port here, so you're drawing air from around the whole canister. It comes in, and then goes through this, center part here.
Right.
Some of these other designs, what they do is they bring in the port basically tangential to your canister so that air comes in at relatively high velocity, and then it gets spun around the outside of this canister.
Okay.
And what the design of that is supposed to do is your heavier particles within the air, if you got pieces of dirt or things like that, those under centrifugal force get pushed to the outside of this canister, and those fall down.
Because
around
it
the
drops in
outside.
velocity then.
Exactly. It slows
Okay.
down when it hits this big open area in here, then those fall down to the outside of the...
Well, this looks like it's kind of the same thing, and it's also a very low pressure.
Correct, yeah. I mean, this is
Yeah.
it's all relative here on a small scale, but you've got basically a smaller inlet and you're coming into a big open area, so your velocity just slows immediately
Right.
once it gets in that area.
And what you're saying, that more than the filter really is why the particles drop to the bottom.
Right, on those designs where it actually comes in, tangent to this,
Okay.
to your canister here. But
That's pretty
this
cool.
Is the same type of
So it's more the slits in here and the design of that
on this one.
on this one here than it is the filter itself.
Right.
Okay. Very cool stuff.
So,
Do you have anything you'd like to add?
no, I think we should go take a look at that 06 Colorado, and remember we were talking about that during the last class?
Yes, we were.
That one?
Yeah, we're going to go take a look at that and have some fun and talk about some different electronics that's going on in there
Yeah.
as far as that vent solenoid is concerned.
Exactly.
Some neat stuff that we had discovered. Would you like to add anything else? Eric?
Nope, that's all I have.
All right.
Hopefully it helped out, just kind of explain some of this.
No,
for us, so
thank you very much. It was
bet.
very, very well done.
thank you guys.
Okay, let's head on over to the car and get this guy back to work.
All right.
Here we are.
Yeah.
With our infamous Colorado.
Yeah. that's,
2005 with a 3.5.
straight 5.
Straight 5. Yeah, lots of 5s in there.
Yeah, there we go.
Okay, and this is the one that had, what code was that?
P0449 vent solenoid circuit control.
Circuit control. So somehow the computer knew
Right.
there was a problem going on with the circuitry.
Exactly.
Okay, interesting stuff.
Yeah.
Let's find out how it knew.
Okay, let's do it. Well, first of all, let's figure out how the circuit all works. We got our wiring diagram up here for a Colorado. You can see power comes in from our canister vent fuse number 59. Or is it 69? Hard to tell. 10 amp fuse comes down to our solenoid into that square box with that dash through it.
Which always means a winding a wire.
Right, so the solenoid's got that winding in it, passes through down to our computer, which it just calls out as the EVAP canister vent solenoid control.
So it's telling us that the computer is controlling that circuit.
Right.
And from our past experiences, the way it controls it is kind of through a switch.
Right.
It turns
Yep,
it
a
on and
switch to
off.
ground.
When it wants that solenoid to open or close, it activates it by closing a switch.
Right, yep. So then our power flows in, gives it a ground, the current flows through that set of windings, creates that magnetic field, and moves that plunger.
Okay, let's go through the diagnostics,
Okay.
how we diagnose this
So
thing.
if you want to go ahead and bring up that picture of where the vent solenoid is on here, it's sitting right up above the spare tire, right next to the canister on this one. And then we also went ahead and back probed the connector.
Right.
And we still have the connector disconnected on there, so it's isolated from the vent right now.
Okay.
So first thing that I would do is check for power going down to the vent solenoid. So pin A, which is this red lead right here,
Okay.
we're going to see if we got power. So we'll hook that into the voltmeter. And then right here, I have a wire coming directly from the battery, from the ground on the battery.
So what we're going to do is verify we have a known good ground here.
Yep.
And we're going to verify that we do have 12 volts coming in.
Right, because we can't use the ground that's on there, right? Because it's a
It should be open.
computer-controlled
Right,
open circuit.
if the electrical wiring diagram is written at rest,
Right.
it should be an open circuit.
Right. So we'll use our own supplied ground from the battery, and there we're at 11.77. our battery is down a little bit just from setting
Yeah,
the
it
key
keeps
on.
dropping every time we stick that in there. We have to
Yeah.
put a battery charger on
All right,
there.
so we do have good ground here. So now we know that we have a good power going in.
Right.
So we could check the
Let's-
ground side now.
Yeah, let's check the ground.
So right now we should read an open circuit. I should be able to put this in, and it'd be no different than it's sitting right now with nothing. This
Right.
lead is supposedly not in the circuit at all.
Right, if it's truly a switch there,
Right,
open and closed,
right.
it should be an open circuit.
Yeah, we have the connector disconnected at the vent, and in the computer it should be disconnected because if it was going to ground right now, our vent would be turning on all the time.
Right.
So I'll go ahead and hook this up. Right away we're reading
And
battery
we have the same
voltage.
reading.
Short to ground maybe?
We have battery voltage. And that's kind of where it's leading us, isn't it?
Yeah.
Either the computer is shorted to ground, right, when it's not supposed to
The
be.
driver inside,
And
yep.
maybe that's what was keeping the solenoid on all the time.
Could be.
And that's why it burned out, could be, right?
Or-
Or we have a wire
Right.
that has rubbed through on a sharp edge somewhere and it's grounded.
Right, yeah, that wire's got to run all the way from back there all the way up to the PCM.
That's what you would assume.
Yeah,
I would assume that.
yeah, exactly. We're seeing battery voltage, but there's something shorted to ground. So
Well, next thing you want to do is load that circuit. Let's
Right.
see if it actually is capable of turning this solenoid on.
right, because remember with resistance testing and stuff, if you have high resistance in the circuit, like if our short to ground has high resistance, it won't actually pass any current through it.
Right.
So let's see what that does. So again, just gonna throw some alligator clips on here, and I have a test light. This will just load up our circuit. You could use a headlight bulb or whatever you have laying around.
Sure.
So I'll hook one lead onto the end here, and the other end right here, and right away, no lighting on the test
And
light.
it doesn't take much amperage to light that light. That lights pretty easily.
Right, so we're reading battery voltage there,
Mm-hmm.
but we're not passing enough amperage to turn on the test light, so I'd say we're not passing enough amperage to close our vent.
That is correct. Yes, I agree.
Interesting. So do we have a high resistance short to ground?
Or if possible, let's
Maybe
check,
some
let's
fuzzy
check
green
that,
wire
make
or
sure that
something?
test light can work too.
And make sure that our power lead coming in is actually able to pass the current.
Right.
So just hang that one back up there. Let's get our ground.
And this is known good ground right to the battery.
So we'll hook this up to here. And then this is coming on that pin A right from our fuse.
And there you have
And
it.
So we're able to pass current through our power wire.
So we have enough current going to it to make it
Right.
happen, but we don't have a good enough ground to actually light this light.
Exactly. There's something going on in the ground circuit.
Mhm.
So we now know that we have battery voltage there, but not enough not a good enough path, I guess, to pass that current.
Right,
So we'd want to measure resistance now, right?
right. Remember, voltage is just the supply.
Right, the
you know,
pressure.
the pressure.
And then, so let's do a resistance check on it. And normally you wouldn't want to do a resistance check to verify a ground type of thing.
You really want to do a voltage drop test.
Mm-hmm.
So be careful when you're doing this type of a test. Don't let it mislead you.
Right. So what we're going to do now is take our battery ground, hook it up here, and then switch this over to ohms. And I'm going to take this ground wire, which is coming out of pin B at the vent, which should be open to ground right now. There
Right,
should be
so-
no path.
Explain what we're actually checking here.
Right, so what we're checking right now is pin B at the vent is this black wire in my hand. And we're hooking this one up to the ohm meter, and then we're checking wherever the PCM goes to ground on whatever pin that is. Eventually we'll get back to the battery.
Right,
So we're checking through this wire, through the PCM, through that PCM's ground cable, wherever that is, and then back to the battery.
right.
So we're going back to the source of the ground, I guess you could
Yep.
call it. So
checking the entire loop.
according to this, we should be open right now. We should still read that OL,
And that's exactly out of limits is what we should be reading.
but we don't.
And we're reading 12.68 K ohms.
Right.
And remember, whenever you're on a K scale, in your mind's eye, think of that decimal point as a comma.
Right.
So we're actually reading 12,680 ohms.
12,000 ohms, which sounds like high resistance to me.
It does. And it's kind of telling us, too, that it's not actually the wire that has rubbed through and you got a direct ground path.
Right, and just to verify that, we unplugged the PCM, so we unhooked our wiring right here. If we go ahead and unhook right here, and you take that PCM connector apart, and you're still measuring between here and the battery ground, then it would go open.
Right.
At that point.
Yes.
So something inside of the computer is either shorted to ground or it's meant to be grounded.
Yeah. And remember the code that we had here.
Control circuit, somehow it has to know.
Somehow the computer knows what's going on in that circuit.
Right.
Okay, so let's go there.
All right, so our computer here isn't really telling us anything at all.
Yeah, bring up the other wiring diagram.
All right, this is from the Grand Prix that we had last week, the 07 Grand Prix. Right here's our vent solenoid, and this one tells us a little bit more information. You can see it comes down, and to me that looks like a switch that would close to go to a direct ground. So then the computer puts it to ground, turns our vent solenoid on.
Right.
But according to what we're testing right now, we're not seeing whatever's right here connected to the end of that little
It should
switch
be
right
at
there.
rest. It should be an open circuit there.
Right. But there's actually a 12,000 ohm resistor sitting at the end of that switch right there, going to ground.
Right. And that's how the computer determines what's going on in that circuit.
Right.
It's actually doing a voltage divide,
Right.
or it's doing a, however you want to look at it, or a voltage drop at that point.
Right.
And that's how it's looking at it. And that's how the computer knows whether or not the integrity of that circuit.
Exactly, and we talked about that in a class a couple months back about that voltage divider built into the computer. So
Right.
it's not only particular to vent solenoids or purge solenoids, it's
No.
any really
Anything
solenoid.
that's controlling like that, you know, anytime you're running current through a winding a wire, it's going to work it that way.
Right, and so they put that high amount of resistance right here because the computer has a predetermined notion of what it wants to see.
Right.
So in the normal rest state, when the vent solenoid is not being commanded on, when it's sitting open in normal state, power is going to flow from our battery through our fuse, and then it's going to actually flow through that coil of windings because it doesn't have a path to ground or a very high resistance path to ground. It doesn't allow the current flow. So it's going to actually flow all the way down to here to the end of that switch. So we're going to read 12 volts. If you were to check pin 10 at the computer right there, you'd read 12
You
volts.
read 12 volts, that is correct.
If your solenoid is in working condition.
If it's not open.
Right.
You know, if you don't have an open winding there.
So in the normal solenoid off, vent solenoid open, normal operation, the computer expects to see 12 volts at its voltage divider circuit in there, and that's how it knows that the circuit is functioning normal.
Right.
And then at that point, the computer will then, when it runs its test, when it closes this right here, sends that to ground, it should see 0
It
volts.
should see 0 at that
It should
point.
see that
right.
drop down to 0.
That way it knows it was activated,
Right.
and it knows that current is flowing through.
And the reason why it's 0 is because our load right here is consuming that voltage. So we'll see 12 volts here, we'll see 0 volts there.
Right.
The load consumes it. The computer then sees that it thinks the vent solenoid turned on. And that's kind of why on the Grand Prix last week we didn't get a vent solenoid control code because
Right.
the solenoid was functioning normal. It was just physically binding up because of that rust buildup and everything.
Right, and we did get a control
Right.
code on this one.
Exactly.
Let's check the resistance on that one.
So that is a good test, and you'll see. And I just
Remember
have it hooked
last
up-
time we got about 20 ohms of resistance on a new and the used one, the one that came off of your
Right,
vehicle.
exactly. This is the one that came off of our Colorado. And let's hook it up here. And there we are, 85, 90,000 ohms roughly.
And it's bouncing
And
all over the place.
All over
If
there.
you got a good connection
100,000.
and something, if you're checking a winding wire and it bounces around like that, that's a pretty good indication you got an issue.
Right. So this solenoid right now is essentially open.
Yeah, it is.
And
That's-
so it
and the
can't,
computer saw that.
right,
It's pretty
exactly.
amazing
It can't
stuff.
pass that voltage through it. So the computer flags it as a vent solenoid control code of 449.
All right, the computer doesn't know where the problem is, just knows that there's a serious problem there somewhere.
Exactly. Exactly.
Very cool stuff.
So this solenoid is pretty easy to, I guess, diagnose on this vehicle because it was open. It wasn't an intermittent problem. It had completely failed.
Not like it was on your car.
Exactly.
And we've gone through that, and that's mainly caused by rust.
Right.
That's what's going on with these things.
Right. And now this one does have quite a bit of dirt
the
and
junk in it. Yeah, we dumped it out a couple times, and there's still a bunch of
still getting stuff out of there.
hairballs coming
So
out.
the filter and everything's doing its job, but who knows? Maybe there was some rust buildup in there, and it caused the thing to stick.
Right.
And maybe the solenoid itself overheated and wrecked the windings inside.
Yep, could have very well.
It's a possibility. And you know what? Since we cut this one apart that was on my Grand Prix, I would be happy to install one of these on my car any day for that problem.
Oh yeah,
For an intermittent problem.
and you know that's what this is all about. You
Mhm.
know, when you got a vehicle, you're professional guys out there. When
Right.
you have a vehicle like this in the bay, and the customer says, "Hey, every so often this light comes on, and you check it, and everything checks out good. The rest of the circuit is good."
Yeah.
Now you have the ammunition, the bullets in your belt that you can talk to your customer in an intelligent manner
Exactly.
to say, okay, this is why this is happening, and my best guess, my educated guess, is that vent solenoid has failed.
Right. It's not just a guess at that point. It's from experience and education, and
Right.
you know what happens with these things internally from moisture.
And I watched the Wells Tech guys, and that's what they said.
Exactly.
Right, okay.
Perfect.
All right. Is
So,
there anything else you'd like
No,
to add
let's
with
see
this?
if let's see what we got for our T-shirt giveaway here. Let's see what we got. Oh, all kinds of answers here.
Oh, good.
All right, looks like Jason came on. Jason said B.
Hey, Jason, you are correct.
Randy and Joseph also came on, and they both said B as well.
Excellent.
So-
They must be watching
Well,
regularly.
they must be.
That's excellent.
Awesome.
Very good. Bring up Mike's email address
Yeah.
if you would, Glenn,
There we go.
and send Mike an email,
Mm-hmm.
and he'll get a T-shirt out to you real quick.
Right, and it looks like Pedro came on, and looks like he's having some troubles with a 2003 Altima. Pedro, if you want to go ahead and send me out an email as well with your problems that you're running into there.
Maybe you can answer that on Friday.
There we go. Happy to get that fixed. And next week, Friday, for the Tech Connect, we're actually doing it live. So Pedro, if you're there, I'd be happy to answer that question for
There
you
you go.
live.
And speaking of upcoming things,
Yeah,
here we go.
our next class.
Next class right here is was an 04 Fusion
Focus. Yep.
Focus, and it had a intake manifold runner control problem.
Yeah, P2004 and P2006.
Yep, and we're going to show you how we went through that and diagnosed it and
Yep.
what the results were. Really cool stuff. You're going to enjoy that.
Interesting system on there.
It is interesting. So anything else?
That's it for me.
All right, that's it for me too. Without you being there, we would not be here. We do appreciate it, and we'll see you again next time in the Wells Tech Garage.
We'll see you then.